this episode of Resilient Business, I talk with PhD stem cell scientist Dr. Christian Drapeau. Dr. Drapeau has been working in this field for the past 30 years after pivoting his former career as a neurobiologist into the field of stem cells. He's done vast research work to develop a way that people can leverage their own body's stem cells for on-demand healing and longevity. We talk about those developments, how it works, and how to synergize those capabilities even further by combining them with PEMF. I really enjoyed our conversation, and I hope you do too. If you like what you see on Resilient Business, please like, comment, and subscribe, and check the show notes for select partner deals and discounts. Here's Dr. Christian Drapeau. Dr. Christian Drapeau, it's been a long time coming. So glad to have you here. How are you today?
Beautiful, doing great. And again, same thing, Joe. We've talked about doing this for quite some time, so that's great.
Yes, and your scenery looks wonderful. Am I catching you off grid somewhere? Maybe not even in the country?
I am in Canada. I am indeed off grid. I come here as often as I can. So I stood up a few minutes ago. It was to turn the solar panel to make sure we're good to go.
Excellent. Great. Well, we appreciate you being here on Resilient Business. I think the audience is going to get a lot out of this conversation. I've been following your work for now close to a year, I would say, and have met a lot of the people that work on your team and have gotten a lot of knowledge and information from them and from you in all of what's being shared so far. And so I'm really ready to dive into this. I think for context, though, if we could maybe back up, I don't know if it's 25 or 30 years, and find out for the audience sort of what got you onto the track you're currently on, and how did that all happen?
Well, in 1995, so my background is neurophysiology, so brain research. And I was hired in 1995 by a company that was selling, at the time, Klamath Lake blue-green algae. Some people may have heard about it. So the idea was to document the mechanism of action, how it was working, active compounds, so that we can support any of the claims that were being made about this product. So we very quickly identified the mechanisms of action and the active compounds for the effect on inflammation, on the immune system, and on the brain, on the mind. Most people taking this product would experience like an enhancement of mental clarity, mental energy. So we very quickly identified all of these, but from a purely scientific standpoint, what was very, I don't know what's the right word, but what was motivating for me is that I came across cases of people who reversed very significant conditions touching the heart, the brain, the liver, the pancreas, the lung, joints, the skin. And the question was, what is this product doing, touching so many different aspects of human health? That was really the question that started this whole quest. We did a number of studies. We did not really find, we got great data, but at the end of the day, none of them was the answer. Until one day I came across an article where in January 2001, and the title is Turning Blood into Brain. The first study, to my knowledge, documenting a stem cell going from the bone marrow going to the brain and becoming a brain cell. We need to go back in 2001 at a time when stem cells are only known to be precursors to blood cells. They make white blood cells, red blood cells, platelets, that's it. And of all the organs of the body, the brain is the one that we know does not repair. So to see a stem cell going from the bone marrow to the brain, I thought was groundbreaking to me. So I went into scientific literature pre-internet. Well, the internet was there, but the literature was not on the internet. So I went to the local library and I looked at anything that I could find, and I found two other articles documenting stem cells going to the heart, becoming heart cells, into the liver, becoming liver cells. So I thought, if stem cells can become heart, liver, and brain, why not pancreas, skin, lung, and the rest? So, and if they can become everything, I thought it's just a matter of time, then they have to be the repair system of the body. So we published an article in a journal called Medical Hypotheses in 2001, suggesting that stem cells are the repair system of the body. And in the back of my mind, what if that blue-green algae was working by triggering the release of stem cells from the bone marrow. And it's simply something that nobody had ever looked at. So that was really the starting point, because we acquired the machine to count stem cells, which is a flow cytometer. And we took a blood sample on ourselves. We were 3-4 in the lab, took a blood sample, took the product, took another blood sample an hour later, and then we saw the whole phenomenon. So from that point on, I started to really dive into this whole world of stem cells. And so that's how the whole stem cell quest, started for me.
Yeah, fascinating. And recently I've heard you on a post, maybe on LinkedIn or somewhere that it was shared, and you were talking about healthcare as a business and the fact that not many people think of it that way. And so there are a lot of messages out there these days, and sort of the shape of society is moving based on what healthcare is telling people as a business. When you started to make discoveries like that, was it motivating to you? Were you thinking about that at the time, where maybe I've stumbled across something where I can help people, get some real results here, sort of out of the, say, conventional establishment medical narrative, if you will? Did that cross your mind at the time, or maybe over time it did?
Well, so we're in 2001, 2002. So we have the idea. I dive into scientific literature. Oftentimes you have an idea, you dive into scientific literature, and suddenly you come across a lot of information that tells you, it's your idea is probably not correct. So I have this idea that stem cells are the repair system of the body. I dive into scientific literature, and everything just adds on to this idea. Actually, the idea is getting stronger and stronger the more I dive into scientific literature. So to me, it was a real thing, but still just an idea. So then we discovered that this blue-green algae puts more stem cells in circulation. We derive an extract. So now I have a product. So we made maybe something like 200 bottles of that product. So now I have a product that puts more stem cells in circulation, and an idea that says more stem cells in circulation could be really good for you. So, but they're just two ideas. So I shipped 200 bottles to a friend of mine. He was a naturopathic doctor in France, and he had access to people that when their doctor is telling them there's nothing else I can do for you, then they're like hopeless. Then they end up going and seeing him. So I told him, give that to your people. I want to hear what's the experience. And so he gave the product to a young girl with spinal myopathy. She had never walked. She had never stood up. She was crawling some on the ground. An older woman with severe emphysema. She was on oxygen tank like 18 hours a day. And a number of cases like this, Parkinson, heart disease, those kind of stuff. And then 2-3 months later, I got back those results, and they were just like mind-blowing, like almost like unbelievable. This little girl, after 3 weeks, stood up for the first time. 3 weeks later, she started walking. After 2 months, 3 months, this woman on 18 hours a day on oxygen, her daughter is describing in a letter, she says, she's thanking you because for the first time in 10 years, she went back to visit the cathedral. She climbed the stairs and she was fine. Things like this. Mm-hmm. So I'm receiving all these stories, and I remember sitting in my office and thinking, super naively, my goodness, we're putting an end to disease. And we've discovered the part of the body, like you don't have any of those problems when you are 15, 20 years old. The reason is because you have plenty of stem cells to offset any degeneration. Later on, these problems develop because you don't have enough stem cells. We put more stem cells in circulation. The power of this is unbelievable, I thought. And then comes the forces of the market, new ideas, the time that it takes for new ideas to penetrate, the money that it takes for new ideas to really touch a society, and then to realize the strength of the medical system into keeping people in a belief system. So that's when I started to face like all these things, and it's been the past 20 years journey, but yeah, very early in that process, the thought that came to mind is that's it. We're putting an end to disease. It was naive. I'm not saying today that we are putting an end to disease. Let me put it this way. We're changing the narrative to health. That's for sure.
Yeah, totally, and that's a great thing to be doing in today's day and age for sure. So you talked about the blue green algae and the lights that went off for you there, and the results that you know saw happening there. But you didn't stop with the blue green algae, right? You kept pursuing, and so what did you do next? You went out and researched more compounds, if you will, or more materials that might get similar results. Can you talk about that?
Yeah. So so when we discovered this with the blue-green algae, we are at the time when we're telling people, oh, we have a product that puts 25% more stem cells in circulation. The answer from any like virtually everybody in the scientific field is so what? Like it means anything, maybe it's bad for you. And for the legal, for the attorney, it would be, oh, that's stem cells. The FDA will shut you down. And so my response was like, well, maybe 25% is not a lot, but if a 40-year-old girl with spinal myopathy starts walking, maybe it's enough, you know? And for the attorneys, I'm saying I'm not doing anything. We're just stimulating a natural function of the body. It took years for this to develop. So what I did next was documenting the mechanism of action. For this to be real in science, we need to have the mechanism of action, the active compound, the proof of concept. So we took a few years to do that. Once this was done, the itch that was in my mind for all those years was we evolve in symbiosis with the environment. It cannot be that there's just one plant having an effect on stem cells. There has to be others. And how do you find them? It's very simple. You look at all the plants that have been documented, used for centuries, that have been used for many different kinds of health problems. So let's go and look at them. They all have, and I would say, adaptogens. You know, the one that we say they're good for almost anything, but we don't really know how, but they're good for everything.
Mm-hmm.
To me, these are the plants that are starting to focus on. Medicinal mushroom, goji berry, seaweeds, that kind of stuff. So we studied all of them. We found that they all have an effect on stem cells. But the effect was different for a lot of those. All the polysaccharide-based compounds, like medicinal mushroom, goji berry, we're feeding that to people, and then we see within 20 minutes a drop in the number of stem cells. So the first time we saw that, we thought, okay, the machine is screwed. You know, we need to clean the machine. Then after that, we get the same results. So we need to change the regions. Then we get the same results. Okay, the antibody probably is contaminated. And then after a while, we need to realize it's a real response. And then we discovered that a lot of these products stimulate the expression or increase the density of the receptor at the surface of stem cells that respond to the SOS molecule, the SOS signal coming from an injured tissue. So stem cells, by responding faster and stronger, they disappear from the blood and migrate into a tissue. So we see their drop in the blood. So that's what we saw with a lot of these products. And then the real big discoveries is when I had a chance to meet people working in remote areas of the world, and I had a chance to travel there. So people working, for example, in Madagascar. And I asked them, okay, what is the plant in Madagascar that everybody go to when they have whatever types of health problems? And there is a product in Madagascar called Vahona. It's a little black bead. It looks like a black pea. And you find that into like their local markets. It's in big bags. You scoop a big scoop in a bag and you eat these little beads. And they're made out of one species of aloe. Of all the 60-some species of aloe in Madagascar, one of them is made to make Vahona. It's called Aloe macroclada. So we derived our own extract of Aloe macroclada. We tested it, and we got the strongest response that we have had so far, almost doubling the number of stem cells in circulation within 2-3 hours. Then I looked in China. Of all the Chinese pharmacopoeia, what kind of plants do we have associated with many, many benefits? One of them is sea buckthorn berry, used in traditional Chinese medicine, Mongolian medicine, Tibetan medicine for disease of the lung, of the heart, the cardiovascular system, diabetes, and to speed up the recovery from bone fracture and burn to the skin. Look at this spectrum. It's telling me probably a stem cell effect. So I went to the Tibetan plateau, found a farm that was harvesting wild harvested sea buckthorn berry. We derived an extract, we tested it, we got a great response. So through this process now, I have 5 of the top plants that we have documented act as stem cell mobilizers, of which blue-green algae is actually the weaker one. It's just the one that allowed us to discover the phenomenon. It's the one with which we have the most studies, the most science, but it's not necessarily the strongest.
Hmm.
So with StemRegen, as we have right now, with the blend of these 5 plants, very conservatively, we put statistically about 10 million new stem cells in circulation after about 2 hours.
Yeah, awesome. And so explain then, going back to the basics of that concept there. You have stem cells in circulation, which you keep mentioning, and that's the product that you've created can do that, can help the body do that on demand, essentially, when you take capsules. Why do we need to do that, number one? And where are these stem cells coming from? Why do we need to release them on demand? What situations release them, just generally? If you could kind of paint that picture for us.
Okay, there's 2 main roles for stem cells in the body. One is repair, one is tissue maintenance. The role of tissue maintenance was discovered as an offshoot of the studies on tissue repair. So a typical study to study repair is you irradiate a mouse and then you inject that mouse, you transplant fluorescent stem cells that contains the gene for green fluorescent protein. So that cell is green, and any progeny from that cell, if that cell becomes 1 million liver cells, these 1 million liver cells will all be green. So you can see where they migrated and where they participated in tissue repair. So you use these animals and then you trigger injury to the liver, to a muscle, to the heart, whatever. And then you observe the process of tissue repair. So as part of these studies, scientists realized that if you trigger an injury, let's say to a muscle, we did a study like this. You see the muscle, like literally, the muscle is destroyed after injection of cardiotoxin. And within 6 weeks, the muscle is all reshaped, but it's green, meaning entirely made with stem cells. But then if you look at the rest of the body after like a few weeks, a few months later, you see green cells everywhere in the body. And the extent of the number of green cells varies from one organ to another. So your liver renews faster than, let's say, your lung, as an example, or your heart. So now the question was, is that really in humans? So there's one way where you can see this in humans, and it's women who received a bone marrow transplant for the treatment of leukemia from a male compatible donor. So that means after the treatment, their bone marrow is made out of stem cells that have the Y chromosome. I can follow the Y chromosome. I can tag for it. So going back to tissue biopsies, so banks of tissue biopsies taken from women who passed, let's say 5, 10, 15 years after bone marrow transplant, you go back to these tissues and you count how many cells do I find of those tissues that have the Y chromosome. And out of this emerge, it's never studied. So it's observations. Out of these observations, we can draw some general time frame. You get a new liver every 2-3 years, a new pancreas 4-6 years, new lung 4-6 years, half of a new heart every 25 years. So keep that in mind. You have an injury, your stem cells are your repair system. But if you just age, you lose cells every day. Every tissue has its own turnover, and it's stem cells that replaces the cells that are being lost. Now, the last piece of the puzzle to understand the whole picture is that you're born with red marrow, and that red marrow converts into fatty marrow that does not make stem cells very early in life. By age 15, you've lost 50%. By age 30, you've lost about 90% of your red marrow, and it keeps going down. And that is reflected into the same magnitude of decrease in the number of stem cells in circulation. That's where your repair power is. How many stem cells you have in your blood that can migrate in various tissues to either repair or maintain a tissue. So if by age 30 you have lost 90% of the stem cells, that means your ability to repair is not the same. We all experience in our 30s, we realize we're no longer Superman or Wonder Woman. We realize I'm starting to not repair as fast as I used to. And then from that point on in your 40s and 50s, you get up in the morning and there are little aches and pains here and there that have become chronic, like they're almost like always there. You don't have enough stem cells to fully repair, and these things become chronic. But the biggest part of this picture is that if in your 30s you no longer have enough stem cells to offset the process of cellular loss, That means you slowly start to accumulate small deficits in your tissues. And a deficit in your what is diabetes? Is losing more than 60% of your cells making insulin. What is heart disease? Is the loss of cardiomyocytes in your heart. Every single degenerative disease is the loss of a type of cell or a type of cellular function that is renewed with stem cells. But if you don't have enough stem cells to renew those cells, that means a deficit grows and it leads you to the problem that is associated with that cellular loss. So I published this view in 2013 in a journal of stem cell research and therapy, where I was suggesting that the fundamental cause of the development of age-related disease is this decline in the number of stem cells in circulation. And I said, one way to test for this, go count the number of stem cells in people who have developed age-related diseases and compare that with people of the same age who are healthy. And now about 50 of those studies were done, and across the board, diabetes, heart failure, atherosclerosis, liver failure, kidney failure, erectile dysfunction, COPD, lupus, Alzheimer's, Parkinson, arthritis, and the list keeps growing. These people all have statistically 50% or less than the number of stem cells that you find in a healthy person. So to answer your question, what is the link between health, the number of stem cells, and where is that working all together, is that your stem cells are your primary response to an injury. Just like you have an immune system, you have a repair system. It responds in the same way. Your injury releases compound that triggers the release of stem cells from the bone marrow, then calls stem cells to that tissue. Your speed and efficiency at repair is completely dependent upon how many stem cells can I release and do I have in my blood circulation. And to keep the health that you have today for the decades to come is how many stem cells do I have in my blood every day of my life until the day I die. That is the importance of stem cells and what they do into your health.
So then, is it correct? The thing I have had a hard time reconciling is I've always learned, and as you just described, with age, your overall supply of stem cells, let's say in your bone marrow, for example, diminishes as that red marrow turns into the yellow marrow, the fatty marrow. You just have less water in the bucket, I guess, to draw from with your cup. And let's say the cup is the mobilizing of the stem cells. Let's say we need to grab some out to do some repair somewhere. And so what I can't reconcile is, as that bucket has a leak in it, a slow leak in it, as we age, there's less overall water in the bucket, so that if we have a repair that might require 6 cups of that water to repair, and we can mobilize the 6 cups when we're young, but as we get older, there's only 2 cups there, but I need 6 cups for the repair. I can only get 2 cups. Are those 2 cups enough to create, obviously they are, to create some degree of repair, but are we losing the overall ability with age just because there are less to scoop up with the cup? Or does that not matter for some reason if we're continually enlisting that water from the bucket into circulation? Maybe I'm not asking it properly, but that's kind of what I'm wondering.
Yeah, it's a good analogy, because I use the same thing, trying to really make an image that makes it easy to understand. I use this image of the bucket. Imagine that you have a bucket. That bucket is the number of stem cells that you have in your bloodstream, and it's your health potential. And then you have a hole in the bucket, and this is all the places where you need those stem cells, so it's leaking. Okay, and then the number of stem cells released from the bone marrow is the water that you put back in that bucket. When you're young, you have tons of water to put back in that bucket, and you're not really having that much of a loss because you're young. And you let me put it this way: the budget is much higher on the money coming out, the water coming in the bucket. As you age, 2 things happen: less and less water gets into the bucket, and then you lose more and more because oxidative stress, wear and tear. You get more and more of that turnover. So your water line goes down, and that's your health level. So it goes lower and lower. But to your question, if I use the water that is in my bucket to basically repair? Am I going to damage that health potential? And now you need to shift the analogy and think of your bone marrow like a well. If you have a well that has, let's say, 10 feet of water at the bottom, and you get a bucket of water out of it, it's still at 10 feet. You get 10 buckets of water, it goes back to 10 feet. Take 500 buckets of water, it goes back to 10 feet. Your bone marrow is like that. So you're born with 100 wells, and you lose wells as you age. But the wells that you're left with, your red marrow is producing. So if you release more stem cells, then you will not have fewer stem cells in the red marrow that you have. So really what matters as we age here is what matters. What I mean is the determinant factor is that it shrinks. Right now, that's another line of study that I would like to dive into. It's fundamental study. So this is like the next 10, 20 years of research. But what is the real physiology of that shrinking marrow? Nobody has ever looked at it. We know it shrinks because we have taken a lot of MRI from people with leukemia of different ages, and across the board, we see that phenomenon. So we know it's very well known, red marrow shrinks, but it has virtually never been studied as a phenomenon. Why? How is it happening? And is there a way to slow down that conversion? Because if we could slow down the conversion of red marrow, I think this would be like a Nobel Prize in longevity. It would be probably like the greatest thing we can do for longevity. So these are things to look at, but it shrinks. There's nothing we can do about it. But the fact that red marrow is productive and can we like deplete it? The answer is no. There's nothing right now in science that indicates that you could deplete it, and everything indicates the contrary. Let me take three examples. Number one, who in our society releases a lot of stem cells? It's athletes. Anytime you go to a workout and you go to the fullest, we can quantify a doubling of your number of stem cells in circulation. So athletes, top athletes release tons of stem cells. Are athletes one day walking on the street and running out of stem cells? No, it's not known. So releasing more does not make you having less power in your bone marrow. It's not a phenomenon. Studies have been done to see how many stem cells are needed to really regenerate your bone marrow. And the answer, I'm going to save all the detail of the study, but if you irradiate an animal and inject one stem cell, you can reconstitute the entire bone marrow. So if you release 10 million out of, let's say, 50 million stem cells in your bone marrow, 140 million can totally do the deal. So it's not an issue.
Right.
And the last way to look at it is that all these ingredients that we know today act by triggering the release of stem cells from the bone marrow, they've been doing this for thousands of years and centuries. For as long as they've been used therapeutically, they've always done that. We just did not know that was the mechanism of action. Are there any negative effects that have been documented over the years with medicinal mushroom, sea buckthorn berry, Panax notogensin, Allomacroclada? No, there's no report of any side effects that have been documented. Mm-hmm. So my point here is that regardless the angle that we look at the problem, nothing indicates that there's an issue with overstimulating your bone marrow.
Mm-hmm. Okay, excellent. And so that's a really good, description of why, how, what purpose does it serve for the product you created initially with StemRegen, which is now the release product.
Correct.
When you created that, it seems like there were some ways to improve upon the entire process of how those stem cells end up being utilized to their fullest in the body. So you went on to evolve the product line, or the protocol, as you guys call it, to
Correct.
include a couple of other products. Would you like to get into describing why you did that and what those are?
Sure. The idea of doing this came pretty much at the same time that I wanted to study other plants, meaning very early in the process. Two things emerged. Number one, the size of a stem cell, about 20 up to 20 microns. It could even be bigger. And the size of a capillary is 12 microns. Understanding that a stem cell can get in a tissue in only one place of your entire blood vasculature. There's one area equipped with the machinery to make a stem cell migrate, or immune cell migrate into the tissues, and it's the postcapillary venule. So in that post-capillary venule, if the stem cell cannot get into that capillary, then the area irrigated by these capillaries have no access to repair. And I think that it is one of the reasons why people carry chronic conditions. Your stem cells are there. They just cannot reach the area. So that area cannot, or the circulation is diminished, so you don't provide enough repair power to really make a difference. And I've developed these products and I've played with it in the past and I've seen the benefits. So I knew in advance that this would really help. So circulation is one. The other one is systemic inflammation. Think of it this way. Well, let me put it this way. It was probably 2002. We had access to 200 patients with Alzheimer's, and we wanted to study the link with stem cells and Alzheimer's. And I thought, this was in the early days, I thought there must be a link between the number of stem cells and the development of Alzheimer's. The hypothesis is that the more advanced they are, the fewer stem cells they have. And interestingly enough, in that group, we did not see that. And later on, Alzheimer's is almost like the only condition where we see the reverse relationship in some studies, where fewer stem cells and more stem cells in people with more advanced Alzheimer's. But what we did see is that the level of systemic inflammation corresponded with the degree of evolution of the problem, of the disease, and the phenotype of the stem cells, meaning what stem cells have on their membrane that we can identify in terms of receptors and protein essential for their behavior. And we found that they had lost the receptor, allowing them to respond to a tissue calling for help. And the reason is that the signal coming from that tissue, which is inflammation, now has leaked and is everywhere in the bloodstream. So the stem cells are stimulated outside of that capillary where they normally get that stimulation to hop into the tissue and migrate. So they're no longer capable of migrating when they get into the circulation. That's the whole general understanding. So I thought, if we have a product that suppresses systemic inflammation, we sort of reduce the background noise, allowing stem cells to better identify where they need to go. So these are the two products that we brought. One called Signal, to reduce the background signal or improve the signaling, if you want. And it's just a blend of plants that have all been documented to reduce COX-2, 5-LOX, the production of various cytokines. So just reducing all this inflammatory load, if you want, in the system. And the other product is a product that acts in 4 different ways to improve microcirculation. So number one, it has nattokinase to improve hemodynamics, like having blood that is more fluid, so you can entrain these stem cells more effectively into the microcirculation. Then a bunch of bioflavonoids to help the integrity of the capillary environment, to make the capillary more elastic, if you want. Then nitric oxide producers to trigger dilation of microcapillaries, and the polysaccharides that help rebuild the glycocalyx, which is this protective layer on capillaries that really, think of it as like moss in a hose. It just makes stem cells slick in the capillary. So that product is called Mobilize, and it basically supports the mobility of stem cells in your blood vasculature.
Yeah, excellent. And frankly, the first time I heard you speak about when it was just released, that had been released as a product, and you didn't yet have the other products, I was listening to it from a PEMF standpoint. Folks know me as the Pulse guy, the PEMF guy, and that's what I do. And PEMF, it just sort of went off to me as a bell, saying, how can PEMF perhaps enhance or synergize with the use of your product to even optimize further the delivery and the effect of those hand in hand, and sort of create a 1 + 1 = who knows how much of an effect, positive effect on the body and on healing. So maybe we could go there and start to talk about any of your thoughts around some of these modalities, and specifically PEMF, and have you given it that any thought in terms of it being synergistic with your product and helping that whole process occur?
Today, I think, based on experience, but also the scientific literature, I think the strongest modality to couple with a product like StemRegen or the protocol that I just described would be PMF. You have that experience, but basically, if we dive in the science of PMF on stem cells, let's put it this way. If you take stem cells, mesenchymal stem cells, and you just expose those stem cells to PMF, you can collect in the liquid in which these stem cells were bathing and proliferating. You can quantify a significant increase in the secretion of various growth factors, things like vascular growth factor, things like brain-derived neurotrophic factors, nerve growth factors. There's even a study where they did a spinal cord lesion, and there were 3 different treatments. One was stem cells release, the other one was PMF, and the other one was a combination of both. And both PMF and stem cells help increase rebuild modality, like mobility, so healing of the spinal cord injury, but the results was by far superior by combining both. So right there's good data showing that the two can work together. The other nice piece of information, and I wouldn't say convinced because I don't know until we know that data. But as I'm reading the data, I get the sense that PMF has been used probably more extensively for joint issue. Is that correct?
Yeah, I would say initially. And certainly as it became more well-known, that was definitely probably one of the biggest uses. And I think it's now, even today, one of the first things that draw people to it is pain. And pain is a lot of times related to chronic joint issue, back, hip, shoulder, knee, that type of thing. So yeah, for the most part, correct.
So that perception or that momentum, if you want, has then led that field of research. So most of the research have looked at the ability of PMF to boost the proliferation of stem cells in joint, their conversion into chondrocytes, osteocytes, to basically build new bones. And the results, this is not one study, this is many studies showing that if you take osteocyte progenitor cells, so stem cells that have started to commit to become osteocytes, then you can boost their proliferation and their conversion in full-blown osteocytes. And I'm saying, I prefaced all of this by saying, I have not seen a study where they looked at this for heart cells, for example, or lung cells, or liver cells. But to see a device or a modality having that impact on the conversion of stem cells to osteocytes, I surmise that we will probably see the same thing in a lot of other tissues. It's just that they have not looked at it, because the emphasis now is we know that it's good for joints, so people are studying joints. So if you release stem cells with a product like StemRegen, with the protocol, so you release them, you reduce inflammation, you allow them to see better where the damage, where the need is, then you open the blood vasculature, and then you apply PMF in that area that further increase blood circulation, stimulate, out of the scientific literature, stimulate their migration into that tissue. When they are in that tissue, they start to release more growth factors and stimulate their transformation into osteocytes and chondrocytes, that are the 2 type of cells that really will lead to the repair of that joint. It's amazing what you have as a combination here. So I would like to do research on this. I would love to find a place when we can do an actual study with joint conditions of both cartilage and bones, and basically use a combination of both, each of them separately and a combination of both, to document what they can do separately, but also what they can do combined.
Yeah, and I think it's super interesting because I think both of our sort of lexicons, our vernaculars, and how we message and tell our stories to people about our respective products here, is that there's a component of sort of acute, or not even acute, but it's a lot of times chronic, but sort of analgesic, pain-related healing, to your point, around joints and around things that people have been dealing with that are musculoskeletal, cartilage, bone, joint, those types of issues. And I think, like to your point, a lot of people are drawn to both of our industries, the stem cell industry in particular, the PEMF industry is rife with people who are looking for those types of solutions. In my education, and what I like to share with the public, and I think where your company is going as well, seeing a lot of the messaging out there, is that it's not only necessarily good when something specific is bothering you or you're dealing with it, but now you can even make it as more of a strategic wellness, longevity, preventative tool. And I think you guys use some of the same messaging that we use here. I talk about PEMF as nutrition for the body, more vitamin than aspirin, although more people are drawn to it initially to use it like they would use an aspirin. Help me with this particular issue of pain, let's say. But the people who do have the most success long term are people who are understanding that the reason why it helps with this particular issue is because it's providing nutrition that the body can now leverage and prioritize how that energy, in this case, is being used to help the body heal. And I'm sure you can formulate the same similar type of message around the use of StemRegen, if I'm not mistaken.
Absolutely. To what you just said, two things that are interesting to add. When stem cell gets into a tissue, the first thing that it does, it suppresses inflammation, because you cannot get tissue repair with inflammation. If you have that experience, if you have an injury and it repairs, inflammation goes down. So these two go hand in hand. So the moment that you start to stimulate the role of stem cells in the tissue through their proliferation and the whole healing process, immediately it will have an impact on pain and inflammation. So that's one aspect. The other aspect, I mean, we use the same kind of message that you described, and I think it's an offshoot of, we go back to your intro, offshoot of the medical system. The medical system is built, and it's not a criticism. And the way that I talked about it over the years, I've never criticized the medical system. I think we just need to look at it very objectively and just see what drives the medical system that we have. And right now, what drives someone's, like, you go see your doctor and you say, I don't feel good, I think I need to go home. Bring me a paper from your doctor. You want to take 2 weeks vacation because you feel that you may have a heart attack? No. When you get your heart attack and now you have your paper from your doctor, then you can have your 2 weeks. Wouldn't the system be better if you catch it before than when it happens? But everything is driven by a diagnosis. And yet we know very well, aside from an acute injury, there is no health condition that when you're diagnosed, that it started on the day of your diagnosis. It's 10, 15 years in development where you see the signs before, but because there's no line where it's caught as a diagnosis, it's invisible to the medical system until one day when you have the problem. And had you done something before, it would have been so much easier to take care of the problem. So what I'm talking about, right? So it was prevention for a while, but prevention is just not having the problem. Prevention is still not making sure that you can enjoy optimal health. So now there's the biohacking that has developed, and now it's pushing. It's still a fringe, it's still like a sliver of the population, but it's this notion to just say, understand that every single problem develops over time. It's best for me to take care at the early onset of it, when maybe I don't even have a sense that the problem is developing because it's subclinical. So I may just realize I'm not running as fast as I used to. I'm not thinking as quickly as I used to. You're far from dementia, but it has started. The process has started. So that's the time when we need to start to do the things that have been demonstrated to do, like, because you cannot show PMF in somebody feeling well and 2 weeks later they say, I still feel well. Then that's scientifically, that's zero. So you need to show it on a condition. So we need to go to the studies that show the benefit on the condition to make that sort of leap and just say, well, it will make the same benefit if I have not fully developed the thing, but I have started to sense that it's developing in me. So that now brings these modalities in everybody's life that is healthy today. But I mean, past 40, let's be clear, we're all developing something.
Yeah.
What we want to do is we want it to not cross the line of the diagnosis or the line where it seriously affects your quality of life before you leave this world. That is what we want to achieve. But we're all developing them to a degree. So the point is, let's start to do this when you're young and healthy so that you can maintain that health as long as you want.
Yeah, and I think
As you can.
the unfortunate thing that I run into is, to your point on, somebody who feels like they're well and they feel fine, and then they do something and they still feel fine 2 weeks later. There are a lot of people who think they feel fine until they feel better than that. And so,
Correct.
And then they don't know why, and they can't understand why they thought they felt good before. It's almost like, I draw the analogy like Tiger Woods. Nobody can argue that he was probably the best golfer of all time. Number one in the world of golf for years and years and years, didn't miss a cut for several seasons in a row. So people would say he's the pinnacle. He doesn't need to practice anymore. Why would he need to practice? But he's out there 10 hours a day still practicing. So very similar concept to that is that
Yeah.
I think even, you don't know that you don't feel you're optimal until you feel you're optimal. And I think that's something that you have to keep chasing, because how do you know when you're there? And so,
Correct.
along those lines, I start thinking of, a lot of the issues in healthcare that we have today, and a lot of the things that are killing people are now, identified as more metabolic conditions. The metabolism is suffering for some reason. And, you could talk about that, the reason why, and whether people agree with that or not agree with that. But I just start to think that, a question I would have, a specific example of that, and a question that I would have for you, if we buy into the fact that metabolism slows down with age, so that if we're able to say something like that, and then we correlate that, or just put on a parallel to that, the 15-year-old with all of the stem cells, lots and lots of stem cells that you described earlier, and then the 70-year-old with a lot fewer stem cells in that bucket that you described earlier. What if we were to compare a 15-year-old from 50 years ago to a 15-year-old today? Would those stem cell populations in those two 15-year-olds be the same, given how society has affected our metabolism and how factors like environmental stressors, et cetera, have affected potentially our metabolism, even at young ages?
Absolutely no data on this. The only thing I can say, which is really not directly to what you're talking about, is that I wondered for a long time. I mean, we've evolved over tens of thousands of years. Why is it that if 50% more stem cells in circulation, it's not a lot, if that makes such a difference, why don't we have it? And then it dawned on me that in my question, suddenly the answer was there, is that we've evolved over tens of thousands of years with a life expectancy of about 30 years of age. So that repair was not significantly needed beyond 30 years of age. So the bone marrow that we have in our 30s is still powerful enough. Like we heal very well in our 30s. And it has not been selected through our evolution. I'm not saying nobody lived longer. What I'm saying is that people made at an age where longevity as a factor has never been selected, and it has never been selected because it never provided an advantage, because most people would die at 30. So we have today the bone marrow that has evolved over tens of thousands of years.
Yeah, it's fascinating to think about, because the other factor that is much different than, thousands of years ago, and really has only been in effect for maybe the past 100 years, thereabouts, is the frequencies and sort of what I describe as environmental stressors, lifestyle,
Correct.
travel, work, debt, the weather, the soil, the water, pollution, toxins and things like that. And so we're exposed to different things that require sometimes for us to use different strategies to defend, combat, protect us from something that's new, something that our evolved, created, bodies have not been used to, have not been accustomed to, have not been forced to deal with and reconcile, for all of human history, let's say, till recently. So that's the kind of thing I think about. And so when I think about your product, I think about my product, I think about the need is amplified over the course of the last 100 years, let's say, to look for strategies that go back to leveraging the design of the body, leveraging, the tools that we have within us to create that healing and that recovery of sorts. Does that make sense?
Yeah, absolutely. There's no question that the body that we have today has evolved over tens of thousands of years with the pressure of certain factors that you described that are not no, they're still there today, but there are additional stressors that were not there during that evolution. So there are a lot of things for which the body is adapting, but is not evolving, is just adapting. And that's sort of the whole world of biohacking in which PMF, is part of, which is, okay, the red marrow is shrinking, mitochondrial function is going down. There's a lot of things that is just happening because this is the body that we have, but we can leverage some of the functions of the body in order to be able to give us quality of life within this extended longevity, because we have gained about 50 years of age extra over the past 150 years, and we're not doing it very well. This extra 50 years, is plagued by so many different conditions that affects quality of life. So what we're after right now is like the body that evolution has given us. How can we leverage part of it to give us quality of life in this extended lifespan? That's really what it is. That's what we're working at. This is our job.
Yeah, and where I go with that is I'm always talking about energy and adding energy to the body and what ramifications does that have. And of course, we see tremendous results of healing and tremendous results of recovery from A to Z. Fill in the blank, whatever you want to talk about. There's a story somewhere about it with tremendous results. And as you've pointed out, you see similar things. For me, it's the addition of energy to the environment that's allowing the body to do more optimally what it's designed to do. And now the way I think about it, I'm not a scientist, I'm not a clinician, I'm a business guy. I just try to think logically and pragmatically. And so when I hear that something is being depleted or weakened or lessened with age, as we've been talking about, I come back to, is that possibly because the body's ability to be and hold energy in the system, its capacitance perhaps, the ability to hold a charge, an electrical charge in this case, has been diminished with age. It's not just because it's time. I have a hard time believing that just because time is passing, these things are diminished. I have to attach some type of reason for it. And so I can easily attach because our ability to hold energy is depleted with age. Now, these other things have a harder time happening. And if I replace that energy, now I can bring somebody back to function as they perhaps did when they were younger, theoretically, is sort of the argument. And so when you talk about the problem of, or the challenge behind red bone marrow diminishing and turning into yellow, if we could slow that down, would energy be something that you would look at to potentially slow that conversion rate down? Or would it be something else? I know you're just speculating.
We need to look at it and study it. Could electromagnetic frequencies of some kind reduce the rate of conversion. We need to study more why this conversion is happening, because sometimes, I mean, things are a decline in the way we look at it, but it's just a process physiologically. It's not negative for the bone marrow itself. So it may not be like a phenomenon that is, let's say, bad or driven by something negative. It may just be like that's bone marrow is not needed past 30 years of age. It's just a process, because at the end
Sure.
of the day, if you maintain full stem cells over the entire life of an individual, you would probably or could increase the probability of cancer. So some part of that conversion could also be a protective mechanism. We need to dig deeper into the study of all of that to see if PMF or anything else could change that rate. But coming back more to
Yeah.
the bigger picture of what you were talking about, I mean, I have not studied enough PMF to tell you that what I'm going to say is what is happening. And probably you'll tell me, no, it's demonstrated. That's what it is. I'm just not aware. But if I just look at it, my training is, I'm a neuroscientist by training. So everything is electricity. Everything is electricity in the body. Every cell needs to have a difference of potential in its membrane. So, and that's electricity. And it's maintained that way by what you just described, the capacity of your membrane. So in order to build that difference of potential, you have ionic transporter that will kick out ions outside of the cell, and then will sort of artificially, or by the use of energy, will build that electricity difference, and will use then that electricity to drive molecule inside. That's how glucose is incorporated into a cell. That's how your nerve system is working. That's how everything is working. So it's almost like you build a dam, you put the water on one side of the dam, and then you release the dam and you use the water that flows as a source of energy to do different things in the cells. That's how a cell is working. So if your cell is losing its ability to produce energy, to be able to build back this electrical gradient in and out of the cell, that cell has become a sluggish cell. It can no longer do what it does. So you can rebuild this charge either by building back mitochondrial function, by cleaning up the cells, or I think that that's one of the things that PMF does. It basically helps the recharge of the cells through electrical discharge, if you want, through electromagnetic frequencies. I have not seen studies documenting that it actually does that, like measuring the electrical potential in the live cells in a tissue pre and post. Has this kind of work been done?
Yeah, I think so. I mean, remember PMF, most people aren't familiar with PMF, and it's a new concept to a lot of people I talk to, but it's been around for years and years and years, probably 100 years, or maybe even a little more, and used on humans, animals. PubMed has studies, dating back years and years and years about, things that I call sort of wonky cellular metabolism type topics, but those are right up your alley. And those are the things that we need to understand in order to know what's really happening. So cellular respiration, potential, negatively charging blood cells so that circulation can be better, back to your earlier point. So some of these things of what's actually occurring in the cell. When I talk about it on the street, to the everyday person, I just talk about it as cellular exercise and cellular energy and stimulating depleted, to your earlier point, low energy, sluggish, you said, cells that aren't doing their job properly or optimally because whatever reason. It could be injury, it could be pathology, it could be age, it could be whatever, pollution, something the body's dealing with. But we just infuse that energy in at the cellular level to help that function, remain optimal, so to speak, either digging out of a hole or piling up more upside above the ground, for the person who's already well, to our story earlier. But I agree. I think the two can be awesome together potentially. And I'd love to collaborate on something like that, sometime in the near future, if we could put it together.
Let's work on it.
Yeah, let's work on it. So as we wrap up here, Christian, this has been great. I really appreciate it. I will include links below in terms of how people can find out more about StemRegen and get more information and look into purchasing the product if they want to do that. I'm going to include this recording in a number of different channels that I have. So hopefully it'll be seen by a bunch of people in the near future. Is there anything that you'd like to add as we kind of sign off and wrap up here?
No, just I mean the summary of everything that we've talked about is that I am absolutely convinced that anybody using your technology, PMF, just add the StemRegen protocol that puts more stem. PMF works on many things, but one of the key things when it comes to repair is that it boosts stem cells. Now give more stem cells to be boosted, and you just boost the outcome. So it's going to be, I think anybody using PMF will see a difference the moment that they start to add StemRegen to it.
Awesome. Yeah, I totally agree. So it's been great, Christian. I appreciate your time. I will let you get back to your lovely surroundings over there, and we'll talk with you soon.
Perfect. Thank you so much.
Thank you.